Sydney Microscopy and Microanalysis is one of 8 core research facilities within the University of Sydney. The facility hosts the headquarters of Microscopy Australia, funded by the federal NCRIS program and state government funding, to provide access to world-class microscopy and microanalysis instruments and experts. The facility spans 4 different locations on campus. Our headquarters at the Madsen building, which houses electron, ion, X-ray, atom probe and light optical microscopy. The Charles Perkins Centre specialises in cellular imaging. Sydney Nanoscience Hub with nanoscale electron microscopy capabilities. And the Brain and Mind Centre focusing on neuromicroscopy. Our centre has a wide range of different microscopy beamlines and techniques available to support research, including light and laser optics, scanning electron microscopy, transmission electron microscopy, ion platforms, and X-ray microtomography. Key to supporting these capabilities is specialised specimen preparation equipment and a suite of image visualisation and simulation software. Light microscopy uses light optical sources in the visible spectrum range to resolve details within a variety of different specimens. Our facilities specialise in cellular and neuromicroscopy. Specimens can be visualised from the micron all the way up to the nanometer scale, using a variety of different probes. This allows for identification of multiple subcellular structures in multiple dimensions, as well as observing the dynamics of biological processes over time. Scanning electron microscopy utilises an electron beam to scan across the surface of a sample, to typically capture topographical information at a resolution as high as 1 nanometer. Advanced SEM imaging modalities allows for compositional imaging, characterization and orientation of elements within materials, as well as high-volume 3D reconstruction from cross-sections. In transmission electron microscopy, an electron beam passes through very thin sections of either hard or soft materials, revealing internal details and composition. Imaging is also possible under cryogenic conditions, allowing visualization of specimens in their native state. Atom probe tomography is a technique which involves shaping the specimen into a fine tip and evaporating layers of atoms from the surface. From this, atoms can be identified based on time of flight, and a 3D reconstruction is created, showing the composition of the material and positions of atoms within it. Microcomputed tomography uses an X-ray source to capture a series of projections of a sample, and allows visualization of the surface and internal structures of specimens in 3 dimensions. Materials that are porous or differ in density are well suited to this technique. The most important aspect of obtaining quality microscopy data is good specimen preparation. Our facility is equipped with the latest equipment to ensure that biological and material specimens are prepared optimally for every microscopy technique. Our visualization and analysis room offers access to high-end software packages and computer workstations to visualize and analyze microscopy data. Many software packages can also be accessed remotely for your convenience. If you are interested in using our facility or want to learn more about us, please visit our website to obtain more information. For general inquiries, please contact us using the details listed, and we'd be happy to assist you with your microscopy needs. We look forward to welcoming you and supporting your research.